chuck, holds the same type of collet. What type of collet is it again? 5C collet. We've got a drill chuck back here. We've got the tailstock back on the end. We've got the headstock up here on the front. We've got the quick change tool post. Quick change tool post because you can take the tool off like this. What type of cutting material is this?
Coated carbide.
What?
Coated carbide.
Coated carbide. Okay. How do you know it's carbide and how do you know it's plated? Coated, actually.
It's gold.
It's gold. How do you know it's carbide?
It comes out. It's a little bit. It comes out.
Okay, it's got clamps that hold it on. Most of our carbide cutters are going to be bolted or clamped on. There are some that are actually soldered or brazed on, but we don't have too many of those. So that's how you'll tell if you have a question. Is it clamped or brazed on? Then it's carbide. If it's gold or just silver, it's either coated or just carbide.
What do you mean by brazed on?
Brazed on. Let's see. This is actually a high-speed carbide tool, or high-speed cutting tool. It's one of the chamfer tools. If it had a little darker gray edge right here, you would have a little tiny layer of brazing, which is usually brass. And you melt the brass and have a flux in there that actually holds the carbide to the steel that could be heavy. This boring bar right here has a piece of carbide brazed onto a piece of steel. You can see the brazing right here, the carbide piece right there. You can't change these. You just basically sharpen them, throw them away. These other ones you can change the insert. Okay, what type of cutter is this?
Regular carbide.
Steel?
See it again?
Carbide.
How do you know it's carbide, Russell Grimshaw?
Because it is mounted in with a clamp and it
Has a
is
clamp
silver.
and it's silver. Okay. What type of cutter is it? Well, the cutter you would hold towards you. So if I was you, I'd hold it like this. Or in this case, hold this towards me like that or towards you. And whichever hand it points to tells you the hand of cutter that it is. So these are both right-handed turning tools. Okay. This has an 85-degree insert and this has a 55-degree insert, being the angle that these two sides would make, and if you measure in between. Which one would be stronger? Which one would break quicker?
The one you're holding?
The more pointed it is, the weaker the insert is. If it was round, it would be the strongest shape because there's not something that breaks off easily. Okay? So the bigger the angle on the insert, the heavier cut you can take. The problem with the heavier cuts, though, is you don't have a lot of options on where the cutter can actually fit. See, this one will fit up a lot closer to this corner than that 80-degree insert would. So they call these profiling tools, and those are turning tools. There's just, you don't need to remember all that. It's just really nice to know from something like this. All right, those of you who are going to be on, well, you're all going to be on the CNC lathe at some time or another. I'm going to show you how to turn this one on, and this one you can't tell what spindle speed it's capable of, but it'll only go to 2,000 RPM. So power on all of these, and then you wait. It's a computer, right? Don't get too excited. Okay, when it says Haas, it's starting to wake up. It's going to come up here in just a minute.
Finding all the swing.
It is. Okay, right here it says the servo is off, and then it flips over to the first page, which looks a lot like our manual. If we go here, you look at the alarm, you go to the alarm messages button right there, and it says the servos are off. And we want to turn the servos on, but I'm going to go to the manual and load first. To do that, you have to push power up restart, but they're all going to give you an alarm that the door is open. that doesn't help. Okay, this one has a switch right here that you could somewhere hold down the whole time you were using it, but that gets really awkward, especially if you need hands to measure stuff with. So we're going to disable the door hold override. We're actually going to turn the door hold override on, and this is done the same on all three machines. And I have a handout somewhere, I think it's on the G drive, that explains this. And what you're going to do is you're going to go to settings, you're going to type 51 in, you're going to go arrow down, and that gets you to the door hold override. It's highlighted as off. We want to push either one of these arrows to the side, and it'll toggle between on and off. As long as it's blinking, it's still not activated, so we want to push right or enter right here. And then it says we're selecting a less safe operating mode. Do you want to continue? And you just say yes, because I'm brave, right? And then power up restart right here. What it'll do now is you notice that it starts turning the handle, bringing the x-axis out to touch a limit switch, and then it's going to go back in. And when it finds the limit switch, it knows where machine home is at. Machine home is the furthest away from the headstock and furthest away from center that the machine can move to. I should have you do this.
No.
You're saying you don't remember this from last semester, Dee?
I don't think I really.
Okay, and then it says install tool 1. To tell it the tool 1 is installed, we push cycle start. So that's saying that this tool right now is tool number 1. So that starts up the machine. To actually start doing it, you have to know what all these buttons are for, what all these buttons are for, what all these buttons are for, what all these buttons are for. But we're going to go to MDI, and I'm going to push cycle start, and that starts the spindle. Now this is an example of our G and M codes. How many G's and M's do you see up there?
I see one S.
One M and an S. Okay, M03 tells it to turn the spindle clockwise. S says the spindle speed would be at 750 RPM or whatever's in there. The maximum that it will go is 2,000. I think I just put 2,000 in, right? We push Alter. Okay, I'll get some better glasses. And that's the maximum spindle speed. Normally you wouldn't want to turn the spindle on if your chuck wasn't clamped on something, but this one we don't have 3 jaws, because the jaws will actually work their way out and come flying out at you. Yes, I have seen it happen too. I've seen just about everything happen. So I'm going to restart it. We go back here now to current commands, and it tells us what the spindle speed is. If it could go faster, we could push this button right here and go up to 200%, but notice it just stays at 1999, 2000, and that's because it's the maximum on this lathe. Let's go back and look at the maximum on each one of these manual lathes so that you know how to calculate the spindle speed when you do your homework assignment. Okay.